All right, let's do one more problem of the type from section 2.1. We're trying to find the relative extreme points, and so we just go through the same process we do to determine where a function is increasing or decreasing, and then the relative extreme points will fall out from that same process. So remember, our first step is to calculate the formula for the first derivative, and so in this case this is negative 3x squared plus 27. Our second step is to find all the places where the derivative is equal to 0, or undefined. In this case, there's no division or square rooting or anything that would cause the formula to be undefined. So solving an equation like this, since there's only terms with x's and terms without x's, there's not several different kinds of terms with x's. This is easiest to solve by separating the x's from the non-x's. And so if we do that, we'll have 3x squared equals 27, meaning that x squared is equal to 9. And so therefore x could be negative 3 or x could be 3. Don't forget we have plus or minus 3 as the solutions to x squared equals 9. So these are the critical values. That's what we call them. That just means that they're important values. Step 3 is to draw ourselves a number line where we are going to keep track of the sign, the plus or minus sign of f prime. And so I'll mark negative 3 and 3, my critical values, on my number line, and I even put little dashes here so I can keep straight my little bins. Here's a point, negative 4, that's on the left side of negative 3. Here's a point, 0, that's between negative 3 and 3. And there's a point, x equals 4. These are x values. That's to the right of 3. So I have 3 different bins, and I can sample values of f prime in each of those areas. So f prime of negative 4 is negative 3 times, I'm just going to do the calculation here. This is my formula, right? The reason I write it down by itself here is so that I know where to plug my numbers in. I'll have negative 3 times negative 4 squared. Negative 4 squared is 16. So that's negative 3 times 16 plus 27. And if you do the math, that is a negative number. So I'll put a minus sign there. F prime of 0 is always super easy. That's why we pick 0 if we can. F prime of 0 is 27, so that is certainly positive. And finally, we put 4 in for x. I'll get I'll get the same thing I got when I put negative 4 in, if you think about it. So what I get before negative, I forget what it was, but it was negative. So also negative. It'll actually match the value you got for f prime of negative 4. So also negative. So this picture in 3 is my sign chart for f prime, and so the conclusion is that my original function f must look like this. It must be going down for values of x up to negative 3, and then for values of x between negative 3 and 3 it should be going up, and then for values of x from 3 on should be going down again. So remember, the derivative sign chart here is telling us the slope. So negative slopes are falling, positive slopes are rising, negative slopes are falling. And so I can see from that that at negative 3 I should have a relative minimum. So the x-coordinate of 3, there'll be a relative minimum. And here, oops, yikes. When I have an x-coordinate of 3, I'm sorry, negative 3, I'll have a minimum. When the x-coordinate is 3, I'll have a relative maximum. And I can tell that from the shape of my graph. It goes down, it comes back up, that's a bottoming out point, and so on. But if you wanted to, you could even pick it up from here. Derivative changing from negative to positive indicates a minimum. Derivative changing from positive to negative indicates a maximum. I think it's easier and more useful to go from this picture to this visualization of the graph. Slopes down, slopes up, slopes down from that. And then from that picture, it's pretty easy to see where you have relative mins and maxes. So that's what I would recommend. The only thing that's missing here are the y-coordinates of our points. So don't forget that to get the y-coordinates, I'm completely out of space here, but to get the y-coordinates, I'm going to use the original function. The job of the original f of x function up here that's a formula that tells us the y coordinates for any x coordinate. So if you know that you're interested that these points where x is negative 3 and x is 3 are important to you, then you should go plot the points where x is negative 3 or x is 3. In order to plot those points, I need to know the y coordinates. So I get that by plugging in negative 3 in for x, that'll be the y coordinate here, and I put 3 in for x, and that'll be the y coordinate here. So that's what my relative extrema will look like, and the shape of my graph will look basically, will look like this shape, but it should be drawn on an axis so that you can see both x and y coordinates of these points, so we have the relative scale correct.